Hey, this is Max McCarty with LockMeDown.com, starting a new screencast series, Lock Me Down Bite Size. And in this screencast, I'd like to talk about leaking data from our application. We're all well aware of the importance for securing confidential information or keeping information out of an attacker's hands that might be able to be used for malicious intent. But what about the information we don't know might be able to be used against us? You know, one of those you don't know what you don't know until it's too late. Well, if we could reduce the data surface area that our application exposes, then we would be limiting the information we're putting into an attacker's hands. And that brings me to what I want to specifically talk about in this screencast, and that is securing our application's cookies. So why would we want to secure cookies in our application? Well, cookies is a container to allow us to move data about our application between parts of our application to maintain state. So if we can directly identify cookies as being part of that data surface area that our application is exposing, then by securing cookies, we would directly be helping to limit that information we're putting into an attacker's hands. But in order for somebody to do anything with the information in their cookies, they have to get their hands on those cookies. How do they go about doing that? Well, there's a number of different mechanisms, starting with sniffing unprotected network traffic. They can garnish information about a victim's cookies that might allow them to impersonate that victim as themselves. Or through the use of cross-site scripting vulnerabilities, where a site that's been compromised might allow somebody to siphon off information in cookies. Or through a man-in-the-middle attack, where an attacker has completely compromised the connection that a victim has with the web server, allowing all traffic from that victim to route through the attacker, and then in return get information out of the cookies. So how can we go about securing our application's cookies? First way we're going to look at is restricting access to the cookies themselves. See, everything that comes in contact with our cookies doesn't need to interface with the information in them. If it doesn't need the information within the cookies, it shouldn't have access to the cookies. We can really look at this first one as applying the principle of least privilege, which we might do regarding security in other parts of our application, where basically we are giving the most minimal permissions in order for a component to be able to do its job. Specifically, we can restrict access to client-side scripts from accessing information within our application's cookies. We can do this at the HTTP protocol level by setting the HTTP only flag on the set cookie header. This is agnostic to any type of framework you might be using. The end result would be, by setting this flag, would be that we're telling any respectable client, such as your popular browsers, not to give client-side scripts access, such as JavaScript, to the information within our cookies. So utilizing ASP.NET Web API, let's drop into some code and see how we can apply this flag on a response that our application makes. As a disclaimer, this is not a screencast on best coding practices or how to build an API. It is about securing our cookies. That being said, let me give a little background to our API and our cookies for clarity of this demonstration. Imagine, if you will, you have a product API where a client can submit a product ID to and get specific information about that product. But in addition, on that response, you also want to provide suggested products based solely on this current product ID request and previous product IDs that have been requested. In order to do so, you're saving the product ID requested into a cookie. Normally, the creation of the cookies might be refactored out to another location, but for the simplicity of this demonstration, I've left it as is. In addition, there are generally better ways to accomplish this suggested product scenario, but I'm using it as a simple background story to the reason for creating this cookie. Normally, we'd start off by doing a product lookup from some data source, the actual information we'd send back on the response. But in the case of this demonstration, what's important is we want to be able to retain this requested product ID into a cookie so that we have it available to us on any future requests by the same consumer. We can do that by creating a name value collection object that can retain any number of name value pairs we'll create a unique name value pair and give it a key of some unique key and give it a value of this particular product ID that was requested. Once we've created the object that's going to contain any information we want to be in the cookie, we can then create the cookie itself. We can do that by creating a cookie header value object and giving it a unique name that we can use to identify that cookie for later use. We'll also provide the name value collection object we had just created. We then need to assign some important properties on that cookie, starting with the domain property. This is going to be unique to everybody's situation, but it generally has to do with the domain that the application is running under. In our case, we're just going to give it an empty string so that the client server will behave correctly in a local hosted environment for demonstration purposes. We'll then set the value for the path property. Again, that value is going to be unique to everyone's situation. We'll then get to the meat of this whole demonstration by setting the HTTP only property on this cookie object. We're initially going to set it to false to see how the client handles this specific cookie when it is set to false. To connect the dots, by setting the HTTP only property on this cookie object is going to dictate whether or not the ASP.NET framework appends or does not append the HTTP only flag on the set cookie header. By setting it to false, it will not append that flag to the set cookie header on this particular response. With our cookie object created, we can go ahead and create the response object that we want to send back. Depending on the ASP.NET application you're working with, your response might look different. The important part is that we're going to go ahead and stick the cookie object we created into the headers of this response. Normally, we'd also at the same time include the product information that was requested and any suggested products that we want to send back. Once that's all completed, we'd go ahead and send this response back to the client. We can issue a request to our products API, and in the developer tools of Chrome, we can take a look at what that cookie might look like. We can see under the name column on the left that we can identify the cookie we created with the name of my app and the values we gave it. On the far right hand side, there is a column with the name of HTTP. This is the column that would give you an indication on whether or not that HTTP only flag was set on the response. In this case, we can see there's no indication that it was, since we set that HTTP only property on our cookie object to false. Furthermore, we could actually look at the headers themselves on the response and indeed see that the HTTP only flag was not appended to the set cookie header. Since the whole purpose of setting the HTTP only flag is to restrict the access that client-side scripts have to our cookies, and since we set that to false, we should be able to validate that we still can access the values within our cookies by accessing the cookie property off the document. And indeed, we are able to see the values within those cookies. So what does this mean from a security standpoint? Well, imagine a very simple example where a site has been compromised through a cross-site scripting vulnerability, and a script has been injected allowing an attacker to siphon off visitors' cookies that pertain to that particular site. Now switching back, let's change that HTTP only property from false to true and see how our cookie looks on the response now. Issuing another request to the products API with the same product ID, we can take a look at what our cookie looks like now. We can see under the HTTP column that indeed it's shown an indication that the HTTP only flag was set. We can further validate this by looking at the headers like we did before and see that indeed the HTTP only flag was appended to the set cookie header. Now that we have confirmed we've set the HTTP only flag on our cookie, let's see what that looks like when we access the cookie property off the document. And indeed, we can see here we no longer have access to those values. Now I'd like to point out we are setting the HTTP only flag on a single cookie. We can accomplish this globally by creating the HTTP cookies element under the system.web section and specifically setting the HTTP only cookies property to true. This essentially will ensure that we set any cookies with the HTTP only flag that weren't explicitly stated. So we've had a chance to utilize the HTTP only flag on our cookies to restrict access to client-side scripts, which helps us against things such as cross-site scripting vulnerabilities. What it doesn't help us against is that person who's sitting there sniffing unprotected network traffic, the same network that our unprotected cookies are flowing back and forth on. So what can we do about that? Well, that's going to be our last way we're going to look at securing our cookies, and that's utilizing the secure flag. It also gets appended to the set cookie header. What the secure flag does is tell any client, such as your popular browser, not to send a particular cookie along on an unprotected request. Unprotected in the sense that you've requested a resource over HTTP instead of HTTPS. You might have taken that next security step by utilizing SSL and locking down all your application pages. The problem comes into play when you or another developer inexplicitly requests a resource either on your application domain or externally, and you request that resource over HTTP, an unsecured request, instead of HTTPS. What the secure flag will do is be sort of that catch-all safety net to ensure that you don't inexplicitly make a request insecurely and send off your application's cookies. So let's take a look and see how we can utilize the secure flag in our ASP.NET Web API example. Inside our cookie object initializer, we'll set the secure property, just as we did with the HTTP only property. We'll set it to false to begin with, just to see how the browser handles the cookie. If you're wondering, false is the default value. So if we issue another request to our products API and take a look at the cookies for that response, there's two important things that we want to take a look at. The first one is on the right-hand side under the secure column, which is the column that gives you any indication on whether the secure flag was set for a particular cookie. In our case, we can see that there's no indication that one was set, which would line up with the fact that we set the secure property for our cookie object to false. The second important factor that we want to take a look at is on the left-hand side under the name column, which has both request and response cookies. To give a little information on how the browser handles cookies, all requests are associated to a domain. Going into how that domain can be set or associated is beyond the scope of the screencast. But basically, a browser is going to look and see if it has any cookies that match the domain associated with the request that's being made. If it does, it's going to send those cookies along with that request. One of the few exceptions to this rule would be when the secure flag is set and a request is made insecurely over HTTP. Therefore, since we've made previous requests to the same products API in the past and received the MyApp cookie, the browser has stored that according to this application's domain and is sending that MyApp cookie along with the request that we just made. If you recall, we set our domain in our cookie object to an empty string so the browser would behave in a local hosted environment. Therefore, since we are making a request insecurely via HTTP and we didn't set the secure flag to true, the browser has no problem sending this cookie along with the request. So let's go back to our products API and make the change to the secure property. So we'll set the secure property to true, and we'll see how the browser handles cookies for this application's domain when we make a request. To start off, I've cleared the cookies for this application domain, so making an initial request, we can see that indeed we are getting the MyApp cookie on the response. We can now also see that under the secure column that we are getting an indication that the secure flag was set for this particular cookie. We can see further validation when we look under the headers for this particular request and see that the secure flag is indeed set on the set cookie header. Now that we received a cookie from this application's domain on the last response, we can test the secure flag by issuing another insecure request over HTTP and see how the browser handles the cookies it already contains for this domain. And indeed, we can see that the browser is no longer sending the MyApp cookie along with any insecure request to the same application domain. As was the case with the HTTP only property, we are only setting the secure flag on an individual cookie in this case. We can do this globally in the web config by setting the required SSL property on the HTTP cookies element to true. And this will ensure that globally we are setting all cookies for this application domain to have the secure flag. So in addition to the HTTP only flag, we've now had a chance to see how we can utilize the secure flag as an additional means for securing our application's cookies and ensuring we're not sending them along on an insecure request via HTTP. So hopefully the information you've learned in this screencast will help you reduce the data surface area that your application is exposing, and in return limit the information that your application is putting into the hands of somebody that might want to do something malicious. For other security topics, look me up on lockmedown.com or some of the other contacts you see here. Till next time.